In this unit, students use what they know about proportional relationships as they investigate slope. They learn that slope In this unit, students use what they know about proportional relationships as they investigate slope. They learn that slope is a measure of the steepness of a line. To calculate slope, students divide the vertical change, or rise, by the horizontal change, or run, between one point and another. They also learn to use a formula and the coordinates of 2 points to find slope. Using what they know about transformations, students can understand that the slope of a line is constant. They can see that no matter which 2 points they use to calculate the slope, they will always get the same result. Students also see that, for a proportional relationship, the slope of a graph is the same as the unit rate. For this reason, the equation of any proportional relationship can be written as y equals mx, where m is the slope. Next, students look at translating the graph of a proportional relationship vertically. They find that the image is parallel to the original line and has the same slope. They also see that it intersects the y-axis at a point that is not the origin. So, they recognize that this new line does not show a proportional relationship, and they connect the amount of vertical shift with the y-intercept. Putting it all together, they see that a line with a slope of m and a y-intercept of b has an equation in the form y equals mx plus b, which is called the slope-intercept form of a linear equation. To graph an equation in slope-intercept form, students use the y-intercept to graph one point on the line and the slope to locate a second point. Then they draw a line through the points to complete the graph. In this unit, students also continue their work with linear equations in one variable. Now they will solve problems that can be modeled with equations that have variables on both sides of the equal sign. To solve these equations, students can combine the like terms by subtracting a variable term from both sides. Up to this point, students have used a solution process that leads to a statement that reveals the solution. But now they encounter equations that lead to false statements. If the final equation is never true, then the original equation is also never true, and so it has no solution. Students also see that some equations lead to statements that are always true. If the final equation is always true, then so is the original equation. This means that it is true for all values of the variable and has infinitely many solutions. This unit also introduces students to systems of linear equations. As they explore systems, they see that a solution of a system is represented by a point where the graphs of the equations intersect, and they recognize that the ordered pair for this point makes both equations in the system true. They find that, just like with linear equations in one variable, some systems of equations have no solution. The graphs of the equations in a system with no solution are parallel, so they never intersect. Other systems have infinitely many solutions. The graphs of the equations in a system with infinitely many solutions are the same, so they intersect at every point. Students build from estimating solutions to systems graphically to finding solutions algebraically. One strategy for solving systems is to use substitution. If one equation is solved for a variable, students can substitute the expression equal to that variable into the other equation. The resulting equation has a single variable, which students can solve using methods they already know. And once they know the value of one variable, they can determine the value of the other. Students also solve systems of linear equations by using elimination. The goal with this method is to get a pair of like terms, one in each equation, that are opposites. Then, when the equations are added, the opposite terms are eliminated, resulting in an equation with a single variable. From there, the steps are the same as with substitution. Throughout this unit, students continue to develop their conceptual understanding of linear equations in 1 and 2 variables, as well as their algebraic reasoning.